What's going on, guys? My name is FiberFlet and welcome to Java 7. Woohoo! In this episode, we're going to be talking about linked list data structures, and we're going to be writing a program that makes a doubly linked list. Firstly, before I get into the tutorial, I just want to apologize that I haven't uploaded in a while. I took a decent break from streaming just to have a break, and I'm back now. We're ready to do videos, and yeah, I'm very excited. This is gonna be our first episode in when we're going heavy in the paint with data structures. This is by far one of the most important data structures to understand, because if you understand how to make this one, you for the most part could program any other data structure. We're gonna be talking about how to make a linked list, which is an example of a linked data structure, where I'm just gonna go ahead and show you guys. So think about a linked list like this. We have one value right here. Let's say it stores value 1. This object, this is called a node, and this object stores two things. Firstly, the value of the node, and secondly, the next node in the chain. So think about it like this. If we had our node object, this would be its value, the value of a node, and then this would be the next node. We would have a variable named next, and that's the next node. That's the node that it's pointing to, and that's how you create a linked list. Basically, you link a bunch of these nodes that are just pointing to other nodes. In this episode, we're going to be making a doubly linked list, which is basically the same thing. However, the node points two ways. It points to the left and also to the right. So a singly linked list is just, it would be either only pointing to the right or only pointing to the left. And a doubly linked list, the nodes point both ways. And yeah, we're gonna go ahead and just hop in the code. I'm gonna show you guys how to make it. Alrighty, so now that we are in Visual Studio Code, if you guys haven't set Visual Studio Code yet, in our last episode, we did go over how to do it at the end of the episode. Your page should look something like this, but if it doesn't, I'm just gonna do it from this menu. You can do File, Open Folder. You want to navigate to somewhere and just make a new folder. I'm just gonna call this not Carl. No. And then we're gonna select that folder right there. And now we're in our project folder. We're not gonna really worry about the overall structure of our Java file. There's a lot with packages and stuff like that. That's for a later episode if we ever are going to cover it. But now that we are in our project file, what we're gonna do is we're gonna hit File. Sorry, not File. We're gonna right click right here, and we're gonna do a new Java file, and we're gonna make a class. Now this is gonna be our doubly linked list class. So we're gonna go ahead and name it doubly linked list. But yeah, now let's get into how to do it. So the first thing we have to do is, we mentioned earlier in our drawing, so we have to make something called a node. Now we're gonna be typing some things called generics in Java that basically allows us to make this linked list have any variable type. So we're gonna go over kind of the syntax for it, and just bear with me. It's gonna be a little bit confusing. It's definitely a very confusing concept. If you guys do want, I can make a specific video about just using generics fully, but for the most part, from this you should be able to get a general grasp of how it works. So we're gonna make first we need to make our node object. This is gonna be a nested class inside of our doubly linked list Java. We're gonna say public class. We're gonna call it node, and this is where a generic comes in. We have to pass something like this. Basically, this is T, the generic T, which stands for type. Basically, when we create our node and also our doubly linked list, we're gonna need that here too. We're gonna do something like, it will be doubly linked list, then this, then we have to specify the type. So if we want it to be a doubly linked list of strings, we would put string there. If we want it to be one of ints, we would put integers there, and etc. You can also make it about objects, and yeah. So that's just the important thing. This is a generic. Like I said, don't worry about too much about understanding how it works. Just know that we need to put this there to make a data structure only take a certain variable, take any type of variable. Next thing we're gonna do is we're gonna add in our brackets. There's gonna be a bunch of errors. Don't worry about the errors. What we need to do is we need to now set up the two variables that we're gonna initialize in our constructor. We have an episode about objects. I believe it's episode 4 of our series. Go watch that if you haven't yet. If you're just kind of tuning in now, that's gonna go over basically how objects work and go and talk about what constructors are if you are confused. As we said before, we're gonna need our value, which we're gonna say t value. Like I said before, t is a generic. Just think about like if we pass integer here, this is gonna tell the program that this is in fact also gonna be an int. And then we're gonna have a node that's pointing to. This is a next node. We're gonna call this node left. Sorry, we're making a doubly linked list. So we're gonna have it's gonna point to two nodes, the node to its left and the node to its right. After we did all of that, we have the free variables that this object will be using. We're gonna go ahead and write our constructor. We're gonna say public node. You don't have to do your generics here. Java knows. And we're gonna have a t value. We're gonna initialize every single node with a t value. Then we're gonna set t. We're gonna want to call this value. You can have the same name in Java. We're gonna do value is equal to val, and then we're gonna initialize our left pointer to null and our right pointer to null. I forgot if I talked about null in a previous episode, but null is basically the empty of Java. Like we'll be able to, null can be assigned to any variable and we'll be able to detect if it's null or not. That's gonna be important for later on when we're writing our like print function for a doubly linked list. So now we can make our node for the most part, but we have no way of accessing the information inside of the node. Now we're gonna need to do that. We're gonna make what are called getters and setters in Java. This is a fundamental thing of making objects that we weren't able to go over in the Carl J. Robot series, just because we weren't doing like fully Java programming. We wanted to keep stuff really simple. Now we can talk about the more complex aspects of objects and overall like complex stuff in Java. So we're gonna make our getters and setters. First, we're gonna make our getters. We're gonna make a public return type of t, as before in more generics, t type. And then we're gonna say get value. It's not gonna have any arguments that we have to pass, and all we have to do is do return our value. So now we're able to access this value by using this getter. So if we're like writing a program in our doubly linked list, we could type node.get value to get the value. We're gonna do the same for our left and right nodes. The way we're gonna do that is we have to make sure that our return type does match this, and it does, so we're good. Like I said, no parameters either. This is gonna be called get left, like that. We're gonna go like that, and then just return left. Now, finally, we're gonna do our public node t, and this is gonna be for our get right, and it's just gonna simply return our right value. Now we're gonna make our setters. This is gonna be along the same lines. It's gonna be very straightforward. We're gonna do public void. This isn't gonna return anything, and it's gonna say set value. And it's going to take a t type val, and then it's simply going to do value is equal to val. We're going to do public void set right. This is a very important one. Make sure it's a node of type, and it's just, we're just going to call it new right. And we're simply going to do right is equal to new right. And then we're going to do the same thing for the left node. Public void set left. And we're going to do node of type t, our generic t, and then we're going to do new left. And if we did everything correctly, this should have no errors and everything is in agreement. This is just an error. Oh, right, because we don't have to put public. This is a nested class. In Java, if you put public class, it has to match your Java name. So we have public class doubly linked list here that matches the Java file name. So Java's happy. You cannot do two public classes. That just sets an error because it needs to have its own file. The main public class of your program needs to match the Java file name. Alrighty, so now that we have finished our node class, we're gonna go ahead and make our doubly linked list. The first thing we're gonna do is we're gonna make a node of type t called front and a node of type t called back. As we said earlier, linked lists are good because you're able to access the front and the back of your data very quickly. So of course we want to implement that. Now in a doubly linked list, the methods that we're going to make is we're going to make an add front, add back. Then we're going to make a remove front, remove back, some peek functions. So like peek front, peek back. And then finally, we're going to make a function that prints it. Yeah, so we're going to make our constructor now. We're going to make a public doubly linked list. We're going to have it initialized with no parameters because we're going to just have it make an empty doubly linked list. Now you may be panicking. You're like, how does Java know what type? It does, Because when we make our doubly linked list, we're going to say doubly linked list. Then in between the two parameters, we're going to have our type, which can be string, integer, or any object. It could be char. It could literally be any variable type. Other than that, we're going to have front start at null because there's nothing there. And we're going to have end start at null. So the first thing we're going to do is we're actually going to make a method that's going to be called isClear. This it's going to be a Boolean is clear. This is going to return if our linked list is clear or not. And simply what we're going to do is we're going to do if our front is equal to null, and actually we can just return. We can just do return parentheses front equals null and is equal to null. If both of these are equal to null, we know the list is empty. If they're both null, we know it's empty. Alrighty, so for our add front method, I want to go ahead and do a drawing for this. So hopefully you guys can better understand how this is going to work. Let's say we have a doubly linked list like this. We have 1, and it's doubly linked to 2. And let's say we want to add in a node of value free. How would we go about inserting this at the front? Well, we kind of want to move everything over. We kind of want to do something like this. We have our node free, and we know that 1, for instance, in this case, is pointing to nothing. So we don't have to change what is to the left of free. The thing that free is pointing to the left is always going to be null. That's always going to be it for a node that's at the front. And we want to insert it where 1 is right now, right? I'm going to erase this here so it's confusing. But we want free to be where 1 is, which means we need free to point to 1 now. So we're going to go ahead and do that. So now free is at the front, and we see that's pointing to 1. 1's pointing, so 1 now needs to point to free to the left. So the main takeaway is that when we are adding a node to the front of a doubly linked list, we need to update what that node is pointing to the right. In that case, it's going to be pointing to whatever values in the front. And we need to update the front to point back to free in this case. So how are we going to do that? Let's go ahead and get into the code. So the way we're going to do this in the code is we're going to do public void. It's not going to return anything. And we're going to call this add front. We're going to pass a generic t value. And the first thing we're going to do is we're going to make our insert node. So we're going to say node of type t. Oh, sorry. First thing we're going to do is we're going to check. We are going to make this node first. We're going to say a node of type t. We're going to call this insert, and it's going to equal a new node. We're going to have to do this and then value. So basically in Java, you used to have to do new node and then do the type again. However, you don't have to do that anymore. They update the syntax. If you put t here, there's going to be an error. Well, there should be an error, and it says redundant statement. You do not have to specify what the type is again here. That's just how it is now. I don't know why you still have to do the angle brackets, but you know, it is what it is. So now we're going to check if our list is clear or not. If it is clear, then we want to go ahead and just say front is equal to insert and end is equal to insert. If is clear returns true, that means our doubly linked list is empty, which means that when we insert our node, we just want to insert it at the front and also the end, because there's only one node in it. So it's that node is the front and the end. Else, we're gonna have to update our pointers, like I said. So we're gonna say insert dot right, because we're inserting in the front. So we have to update its right pointer. So we have to do get right is going to be equal to front. Now we have to update the front pointer, because the front pointer has to point back now, because it's going to be in the second spot instead of the first spot. So we're going to do that is we're going to do front dot set left to insert. And now once we've done that, we can insert our insert node. There we go. The Java was updating. So now that we've done this, we can go ahead and put this node into the front position. And with that, we've successfully added our value to the front of the linked list. So now I'm going to go ahead and write the add to the end method. You guys can go ahead and pause the video here and try to write it yourself. And yeah, I'll be right back. It'll be basically the same thing. Alrighty, so now that we're back, your at end method should look something like this. It's going to be the same for the first part. We just make our insert node with value. If it's clear and we're adding to the end, of course, it has to be the front and the end. Now, this is where it gets different. Because we're adding the node to the end, the endmost node will always be pointing to null to the right, which means that when we make our insert node, we do not have to worry about updating that node's right pointer. We need to update its left pointer to point to the old end. Now that we've done that, we need to update the end's right pointer, because the end before was pointing to null, but now it's pointing to the new end. So we do end.setRight to insert. And then after we've done that, we know that we can successfully update our end to insert without messing up our order. Now that we've done that, we're going to go ahead and do our easiest methods of the tutorial. We're going to make our public type T, and it's going to say get front. That's simply going to return front.getValue. We're going to return front.getValue. If it's not null, actually we do want to check for that. If front is, so we want to say if front does not equal null, we can go ahead and return this. And if not, we return null. Simply as that. Next, we're going to do our get back, which go ahead, pause the video, write your get end. Go ahead, write your get end function. And I'll be right back. All right, so now that we're back, your get end function should look something like this. Basically, we check if the end is null. Is not null. If it's not null, then we know it has to be a node, so we're able to return the value. And if not, then we know that the ending is null, so we have to return null. Now we're gonna add deleting our front node and deleting our back node. So the way we're gonna do that is we're gonna do a public void, and we're gonna say remove front. We don't have to pass any parameters. All we have to do, so when we're removing the front of a linked list, all we're really saying is that we are making the front whatever it's pointing to the right, because that is the next value in the linked list. So we really just have to do front is equal to front.getRight. That's just going to be the next node. If getRight is null, then it's just going to make front null, so it shouldn't have any issues. We're going to make the same thing for the end, which you can basically assume. I'm not even going to say pause the video because you guys can figure out how to do this. End is equal to end.getLeft because it's pointing to the leftmost value. So now that we've done all of that, the last thing we want to do is we want to make a print function that's going to print out our whole linked list. So we're going to be able to test it. Now, the way we're going to do this is really going to showcase how the linked structure works fully. If you're still not fully grasping what it is, if I'm not doing the best job at explaining it, this should hopefully add some clarity to it. It's going to be public void. It's going to be called print list. We're going to go ahead and add brackets. And what we're going to do is we're going to use a while loop. First thing we're going to do is we're going to make a node of type T named target. Sorry, a node of type T, generic T, target, and that's going to be equal to the front. We're going to be getting all the values from the front of the list. We're going to go ahead and set that up. Now we're going to use a while loop. I spelled target wrong. There we go. So we're going to say while target does not equal null, because eventually we're going to hit null, because we're going to be going to the right, to the right, to the right, to the right. And we're eventually going to hit null. We're actually going to want another thing that's going to be called print string. And that's simply going to be that. We're going to have to say string, print string. There we go. Boom. We're not in Python. So now we say while target does not equal null, because eventually target is going to be null, because there's eventually going to be an end to our linked list where the rightmost node is null. We're going to simply do print string plus equals target dot get value. Then we're going to do plus a space, so everything's just spaced correctly. And then we're going to update target. We're going to say target is equal to target dot get right. So when we're doing this, basically we're taking the value of target and then we're updating target to its rightmost node. We're just making it inch slowly down. So actually, if we pull up our example earlier, think about it like this. Our linked list is free pointing to one, pointing to one, and then finally pointing to 2. What this function is doing is we start at free, we append free to our return string, then we call right. Its rightmost node is 1. So now we're at 1. We add 1 to the return string, and then we call right again, which gets us at 2. We add 2 to our return string, and then finally we go 1 more. Remember that 2 is pointing to null here. Our while loop would then exit because our target is now equal to null. Then we get this return string and we simply have to print it out. So the way we're going to do that is we're going to simply just call our classic system.out.print new line, print string. And now that we've done all of that, this should be good. This should be our linked list. We're going to go ahead and just make a new Java file now. Remember, we right click here, we do new class. We're going to call this doubly linked list tester.java. We're going to go ahead and make our public tag void main string args, the classic. Now, Java is smart. Unlike other languages where you have to add an import statement to tell Java to look at another Java file, as long as your Java files are in the same directory, you do not have to worry about importing another Java file. So we're actually able to just do doubly linked list. We're going to make a type integer first for types. For first test. So we're going to put integer in between our generic like brackets here. Eventually, we're going to be talking about something in array, called an array list, and it's defined the same way. So I know this is new. I know it could be kind of scary, but don't worry, we're going to be fine. We're going to call this test1, and we're going to make a new doubly linked list, and then we can go ahead and call it like that, and we're good. As we said before, it initializes as empty, so we're good to go on that part. We're going to go ahead and add some stuff. So we're going to say test1.add front first. We're going to add a 1 this time. Your editor, depending on which one you're doing, your IDE, it might do this differently. The way I installed Visual Studio Code, it's up like this. Don't worry about it. You don't have to type value 1 here. You just have to put 1 in between the parentheses if your Visual Studio Code isn't doing that. Then we're going to say test1.add end, an integer 2. And then finally, we're going to do test1.add front 0. And yeah, we're going to go ahead and then print out the list. We're going to do test1.print list. Then we're going to test removing it. We're going to say test1.remove end. That's going to remove the 2 from the list. Then we're going to go ahead and then we're going to print out the list so we can show that. And then we're going to go ahead and remove front, which should remove the 0. And then we're going to write a couple more tests before we run this. Yep. We're going to make another doubly linked list. I want to show you guys. We're not going to write full test first, but I still want to show you guys that you can make one of strings because we set it up with generics. So as you can see, we have no errors here when we do this. And then we do test2. We're just going to append one thing. We're just going to test2.add front, add end, FiberFlet. And then we're just going to print the rest. Like I said, I just want to show you guys that you can do it with any object type. This print list statement, do not try that with other object types. I just wrote it in a quick way that would make sense for a majority of the data types, so you will be using it. But if you have a unique object, it's gonna have a stranger output. But anyway, yeah. If we wrote our doubly linked list program properly, this should run. We're gonna go ahead and run it, and we had no errors, which is perfect. We add to the front. It looks like our remove method is not working. So here it's fine. Actually, we do want to update here. We want to make sure that our new front left is still null, because our new front.left right now is actually, sorry, our new front.get set left. We want to set left here. Our new front.left right now is still pointing to the original front. So that's why we're having that error. And that's why we weren't getting that for our other ones was because we were printing from the front. So we were never calling left. We have to do the same thing here. We're going to say new end dot set right to null, because it's the new end one. So the end has to be pointing to null. So now with these changes, if we do run our tester, it should work. As you can see, it does. We remove from the end first, then we remove from the front. And we can also see that FiberFlet string is printed out. But yeah, thank you guys all for watching. Next week, I believe we're going to be talking about array lists. And if I'm not able, array lists. And if I'm not able to have a full episode about array lists, we're going to talk about utilizing more functions of a doubly linked list. So for instance, have one that's always sorted. Let's say we had an integer, a sorted doubly linked list. We'd have to have it as integers or doubles. But yeah, other than that, thank you guys all for watching today's episode. I apologize again for my extended break, but we're back now. We're also streaming. That's going to be on my Discord. There's going to be a link to my Discord in my description that has my stream schedule. It's also going to be posted on my X, so you can catch me there. And if not, I should have a new video out next week. And yeah, goodbye everyone. Peace out.